name is Phoebe Nonis, Senior Manager for Trade Services at the BMCC, and I will be your MC for today. We are delighted to have with us today Datuk Sri Johan Raslan, Council Member for Climate Governance Malaysia, and a steering committee member of the CEO Action Network to give the opening remarks. Please allow me to share some information on Johan. He is a member of the Institute of Chartered Accountants in England and Wales, or ICAW, and a former executive chairman of PwC Malaysia. Johan is currently a board member of Sime Darby Property Berhad, and he has served on 2 other public listed company boards in Malaysia. He is also a board member of the Institute of Corporate Directors Malaysia and on the Audit Oversight Board for the Securities Commission. Johan is an Eisenhower Fellow and a former president of the Kuala Lumpur Business Club and a 30% Club mentor. With that, I would like to invite Johan to give his opening remarks. Johan, the floor is yours.
Thank you very much, Phoebe, and thank you very much to BMCC for putting this together. I'm looking forward to it myself. Thank you, and thanks for the kind introduction. As you heard, I sort of represent CAN, which is an association of CEOs in Malaysia who care about sustainability, and also Climate Governance Malaysia, and that is an association of non-executive directors who care about climate change, and we collaborate in a number of areas such as this. And one of the areas of collaboration is to bring you engineer Ashwin Threra. Ashwin, let me introduce you to him, is executive director of Green Re. And Green Re is Green RE is the leading green building certification body in Malaysia. And they are supporting CAN and CGM in developing proposals right now on climate change to the Malaysian government. So here we are, a whole lot of collaboration coming together along with BMCC, allows us to bring you Ashwin, and of course, more importantly, the 3 excellent panelists that you have today that I've been fortunate enough to meet beforehand, and I'm looking forward to this a whole lot. Thank you very much, Phoebe. Thank you very much, BMCC, and over to you, Ashwin. Thank you.
Okay, thank you very much, Datuk Sri Johan, and to the organizers, the British Malaysia Chamber of Commerce. I wish to extend a warm welcome to our esteemed speakers today and attendees. Firstly, to set the scene, as part of the Paris Accord, Malaysia has committed to a 45% greenhouse gas emissions intensity reduction target from 2005 levels by 2030. Further, in 2021, as part of the 12th Malaysia Plan, our Prime Minister has set a vision to achieve net zero carbon as a nation by 2050. Now, this is a very ambitious target. I'll just share some quick figures to give an insight as to the scale of the task on hand. Firstly, the built environment is responsible for 40% of these greenhouse gas emissions, 3/4 of which are operational carbon and the balance embodied carbon. 50% of all electricity produced in the country is used in the property and construction sector. 90% of Malaysia's population is estimated to be living in cities by 2050. And further, 2/3 of the building stock that is estimated to be there in 2050 are here now, whereby upgrades and retrofits will be necessary to reduce their carbon impact. Green Re has been supporting the CEO Action Network and Climate Governance Malaysia, working very closely with Datuk Sri Johan to refine policy action, provide proposals to refine policy action in Malaysia to address climate change in the built environment. Now, I'll just share a quick graphic. Summarized in this graphic are the key action areas that we have put forward to the government. Firstly, to reduce operational and embodied carbon, we need to focus on energy efficiency for new and existing buildings. We need to replace as much of grid-connected electricity with renewable energy. We need to increase the adoption of low-carbon materials, in particular green cements, which are abundantly available in Malaysia, and increasing the use of low global warming potential refrigerants. And this has to be followed on with waste minimization, promoting recycling and the adoption of IBS. Governance and awareness of sector greenhouse gas emissions are equally important. We need to improve our governance structure, get the follow through from federal government all the way down to state and local authorities, better coordinated. We need to improve capacity building. This is both in the government and private sectors. And the creation of a greenhouse gas database. We need to know where we stand and whether the actions we are taking us in the right direction. So in a way, we need to smarten our cities. And lastly, we need to conserve biodiversity and the natural carbon sinks in the environment. So these are three key pillars that we need to focus on. And today, to gain some insights on the technological solutions from the UK, particularly on how we use our energy and also how we can smarten our cities. We have Stuart James from Malak Energy, Diba Salam from Studio DS, and Robert Eason from Eason Energy. Before we dive into the presentations, let me just pass the floor around to each of them for a quick personal introduction. Stuart, over to you first.
Hello, yes, good morning and good afternoon. Nice to be here. Thank you for the invitation. My name is Stuart James. I'm the sales director of a UK-based renewable energy business called Malak Engineering, and I've personally been in with the renewable sector since 2001, and our specialist area is off-grid renewables, supplying systems for off-grid electrification. So very nice to be here.
Great, thank you, Stuart. Diba, over to you.
Hello, it's very nice to meet all of you. It's good morning from London, but good afternoon to all of you. I'm the founder and principal of Studio DS. We're an architectural practice based in London with offices in Dubai and Bangkok. Had about almost over 10 years experience working in Southeast Asia. I'm looking very forward to discussing from an architect's perspective, smart cities and how to master plan smart cities.
Thank you, Diba. Good morning to you. And to Robert, lastly.
Well, good morning, everybody, or good afternoon. I'm in Bangkok, so good afternoon. Eason Energy are a UK-based energy efficiency company. We are one of the very few in the world that look at a whole-of-site solution, not just looking at lighting or motors or anything else. We work extremely closely with our partners from the renewable sector. And as part of that, I've been a conservationist, not a tree hugger, but a conservationist pretty much all my life. My father was the one that started me off, switch the light off. I think that was said more often than I love you, son, in the house. So I'm looking forward to the presentations today. The light's finally been switched on for me, Diba, with Studio DS. Now I know what the DS stands for. Fantastic. Looking forward to the presentation today.
Okay, thank you to all of you. I certainly am looking forward to all the presentations. Without further ado, pass the floor over to Stuart to begin his presentation.
Right. Okay. So yeah, as I say, my name is Stuart James, and I'm the sales director here at Malak Engineering in the UK. We are primarily a manufacturer of renewable energy products. So we manufacture a range of wind turbines, and since the 1980s, we've also been a supplier into the industry of lots of different solar panels and PV systems. We export to 50 countries or over 50 countries in around the world now, excluding Malaysia at the moment. So that's something we're targeting at the moment. We export to Australia, obviously lots into Europe and the US and Japan as well. So we are based in the UK, but we do have distribution and customers around the globe. As I say, primarily our business is the manufacture of small-scale wind turbines. So these are manufactured by us in the UK, and all of our wind turbines are designed for off-grid battery charging systems. So we have different turbines for different applications and different industries. So we start with a very small wind turbine, which is the Rutland 504, which is primarily used for the leisure market, but in terms of products which are used in industries and by the utilities, we have various other wind turbines. So the 910-4, the Rutland 1200, and the Rutland 1803. Now, as I say, these are all designed for battery charging systems, and I'll come on to and how we integrate those into with solar panels as well. But these are all designed for companies, individuals, utilities who want to run specific equipment off grid. Now, that may be because of the cost of grid connection. It may be due to the fact that there is no grid connection within a short distance of where the equipment needs to run. And so as a company, what we do is, using our wind turbines and our understanding of solar, is we can put together a complete off-grid power system bespoke for the customer's requirements. So that also includes solar panels. So we have lots of ranges of solar panels. So we have Ameresco, who are a US-based company who design and manufacture very high-quality, professional-grade solar panels. We have Alpex, who are based in India. We also manufacture or have manufactured panels to our own specification, and that's the Spectra solar panel range. And we also have some quite bespoke and niche type of solar panels, which are non-glass, semi-flexible solar panels. So these are used in lots of different industries, but we find that they're used more and more now by customers who want to use solar, but they don't want glass panels. They want a panel perhaps that can be stuck onto the side of an enclosure, or is quite hard to see from ground level. So the semi-flexible panels you can see there on the right-hand side, which we have from 2 or 3 different manufacturers, non-glass, very niche, but very useful panels. So where we use this type of technology, these are just some examples of systems that we currently offer to customers. So we've got a very diverse customer range, and this is the same with customers all around the globe. So we have certain customers in the rail industry, for example. So the system on the left-hand side there is a pedestrian crossing on a rural railway. So that's an area where people cross over a live railway, but they have a camera there to make sure there's no incidents and just for monitoring. But there's no available power. So the nearest power source from that system was around about 2 kilometers away. And that would cost perhaps in the UK, £20,000, £30,000 to dig a cable, the trenching and all the civils that's required to bring power to that sector. So it's quite achievable to run a camera, for example, to have a small wind turbine and a solar panel system charging up a bank of batteries in the base of that column that can actually run that camera. The system in the middle there, that's for lighting. So that is a retail park, which the more and more of them are outside of big towns now in the UK and in Europe. And so an easy way to electrify a wayfinding sign or a sign of what retailers are on the site is by running it from solar. So that's called a totem sign. So we work quite closely with the sign manufacturers. They tell us the type of LEDs that they're using, the power requirement they have, and we can design a solar panel system to fit around the physical sign, even in the UK with our lack of sun in the winter. So we're able to calculate the size of the system, the amount of renewables required to run that system all year round. The system on the right there, that's just a bit of a novel system. Many years ago in Iceland, in Northern Europe, there was a volcanic eruption that caused lots of problems with commercial flights that had to be either halted or diverted. That volcano is now covered with seismic monitoring equipment, lots of which is ran by equipment that we have supplied. Again, some more examples here. Utilities, so we work lots within the oil, gas and the water utilities industry. So if there's a gas pipeline that they want to monitor the pressure, for example, and that information is fed back to a research station or head office somewhere, a lot of that equipment is quite remote, and again there may not be grid power available to run that monitoring equipment. So it's very within our realms to design a system based on what the customer needs in terms of their power requirements to run remote sensors and remote monitoring. Traffic cameras as well, more and more monitoring of highways and major roads in the UK and also overseas. Again, lots of those cameras, they could be number plate recognition cameras, they could be speed cameras, lots of that equipment. The road utilities want to run those remote from the mains. So again, we can design a system based on the power requirement of the equipment to run those cameras and those sensors. Lots of the systems we design and supply are based on a combination of wind and solar, but we are very good at designing systems based on the environment they're going into. So we have some great software that enables us to design systems using solar. So we can look at geographic and locational weather data for the last 20, 25 years. So we can really design a system that we know is going to stand up all year round, no matter where it's going. So that could be a combination of wind only, it could be a combination of solar only, or it could be a combination of the two. But ultimately, all these systems are designed for off-grid battery charging to cut the cost of bringing in grid power. And obviously, once those systems are up and running, there's no ongoing cost and there's no civils required as well, apart from the pole that everything sits onto. So we're very active around lots of different industries, and we are more than happy to talk to any of your delegates after the presentation if they have any requirements and any questions they have about off-grid power supplies and systems. So thank you very much for the opportunity.
Thank you very much, Stuart. Very insightful indeed. Bespoke off-grid renewable energy solutions. Just a reminder to all the attendees, you can put your questions down on the chat group, or the chat box, the Q&A section rather, and we will have the questions answered later on during the moderated Q&A session. Okay, next up we have Diba Salam from Studio DS, who will be talking about smart cities and smart technologies. Over to you, Diba.
Thank you, Ashwin. And thank you, Stuart, for very insightful product analysis of things that we essentially will specify. As an architect and as a master planner, we are working on projects right from the inception. And if you're not aware of the Royal Institute of British Architects Plan of Works, we start from the strategic definition of a project right till the in-use works, and throughout that whole process there's a huge amount of work that has to be carried out. We are signatories of the Race to Zero, which I'm sure many of your audience now are becoming more and more familiar with the United Nations SDGs as well, to determine their own ESGs, which we get involved with quite a lot because of the very point that we work right from the inception of a project. And I think one of the key things that we'll be highlighting today as well is collaboration, that not everyone knows the answers, and that's absolutely fine. We don't know how we're going to get to net zero 2050, where everyone's got great ideas, and it's working together to see what works, what doesn't work. And that's what I'll be sharing a little bit about, that kind of process that you go through. We work very closely with the UK Green Building Council and World Green Building Council. I was their UK ambassador to COP26, which was a great experience, experiencing all the different policies, all the different stakeholders that make up the carbon targets for various different countries. I'm going to share my screen now and take you through some windows. So today we're going to be talking about master planning smart cities. with any master plan, you need a smart strategy. And at the very heart of it is the people, the citizens. And how you get to that point is certainly a challenge, which I'm sure a lot of companies are going through right now. Essentially, we are at a very critical moment where all companies, all governments, all citizens really are participating in recognizing that we are at a very important and pivotal moment where the climate disasters which you see around the globe are really impacting people's lives. And making sure that we have resilient cities, and certainly when you look at Asia and the large influx of people to urban areas, but also the population increase. This is one of the largest challenges for any country, any government, and making sure that those cities are resilient is probably the biggest challenge. Something that we always advocate for all our clients is some form of structure. And so we follow the UN SDGs, which are the sustainability goals. And not all types of the goals are reflective in every project, but it allows us to have a checklist that we are maintaining, key components which are essential to the ecosystem of a project. So when you look at these, the various figures of, Ashwin, can I just double check? Is my screen changing?
Yes, it is. Yeah,
okay,
it's
fantastic.
on the time for change slide now.
Okay.
Yes.
Good.
Okay.
So as I say, we're signatories to the Race to Zero. We are very much working with actually companies looking at their own ESGs, so that they know that when they start the project brief, they are in a very strong position to be able to advocate for not just their own ESGs, but also for the country's direction, be that net zero carbon or the 45% reduction. So when we look at smart cities, there are so many different definitions, but essentially the key components that you will always see is, technology, sustainability. And I think that's probably the most important part to understand that, this is a fantastic era of technological advancement, and it's using that responsibly and sensibly for the design and the creation of smart cities, the upgrading of infrastructure, so that it can serve citizens around the globe who are effectively being impacted by whether it's climate change or high energy prices or energy in itself. So it's when you start to look at all the various players, and you understand that, okay, well, we've got a very huge task. This is where collaboration comes into it. And when we talk about collaboration, we understand what are the key components to serve a citizen, to make their life livable and happy in their own environment. And in order to get to that point, there are so many different players. And this is one of the key things that we always recognize, that in order for us to be able to target net zero carbon, we do have to collaborate with all of these vested interests. So whether it's the public body, the governments, to the semi-private, semi-public, and large companies and tech industries, to academia and the private citizen, that dialogue through whether it's social media, through government services becoming online, that's all part of the smart journey that we have to create in our cities. So as architects, we are very much keeping our fingers on the pulse to understand, well, what are the standards out there? What are the key directions? How can we learn from other industries, other countries' stories, essentially? What's worked, what hasn't worked? And one of the key things that we certainly will find is, when you start a project, you can start the project, 5, sometimes even 10 years before it will even become operational. So understanding how to future-proof and design in resilience into those projects, into those master plans, it's probably one of the most important parts of it. We were working on a project in Phuket. These are some of the examples of how we communicate those very complex networks of ideas, players into something that is a very easily understandable diagram. And for example, one of the projects that we worked on was Central Phuket in Phuket. We started the project in 2014, and Phuket had declared itself a smart city, that it wanted to create this a new environment post-tsunami. And the client we were working with, there certainly were, there was a difference in the maturity level of, well, this is what we're ready to do. This is what's ready in the market in terms of technology. And so the highlight of that is, well, we need to make sure that the master plan is resilient. We need to make sure that we factor in future-proofing technology so that when the time comes, you are ready and you are able, and they're certainly ready now. And it's a fantastic story of how, a large developer can actually impact, the city living. And that starts right from the very beginning, where you say, right, okay, what is the diagram? What am I trying to achieve? And I think all of these different images start to highlight, well, there are various scales of master plans. So you could be a developer who is looking at a series of maybe 5 buildings. You could be a developer who's looking at a series of districts, or you could be even the government, where we were working with one of the states in the UAE, where they had a huge amount of plots of land and they didn't quite know how to coordinate all of them. And so, the first opportunity we had was to say, right, let's start to organize it. And this is where you will see, say, for example, when Stuart shows you the wind turbines and the various technologies that you can bring in, just like that, engineers, architects, we're all working with AI, we're working with algorithms that can help the design process get to the point where we're able to implement all those various technologies onto our designs. And that communication of ideas isn't just to governments for approvals. It's not just to the developers, but it's also to people through the planning system and how we actually communicate those ideas. And, a vast majority of our projects will always start by, this is how you will provide we'll provide security for you through these various technologies. And I think that's another nugget to take away from certainly master planning smart cities is the security around the infrastructure that is being put in place. But the way in which we will generally work is we will work to standards. So say, for example, the UK and the Malaysian government, they commissioned a very good report on smart cities. And, this is the cross-learning, the cross-fertilization between ideas. And when you look at the British standards for designing smart cities, you look at then the developers' own ESGs, then you're essentially starting to build a picture which will help you design a system that incorporates healthy neighborhoods, healthy communities. And we should never lose sight of that. And another key component to all of this is we need data. We need to have science-based targets, and we need to have the science behind that to understand how are we going to get from A to Z with the information that we have got. What is the information we need, and how do we engage with various government bodies to ensure that whatever they are capturing and sharing is benefiting, the wider built environment ecosystem. So this just gives an example of how, before we start a project, we will start to understand what are the climatic conditions, what are the key components for the demographics, what are we trying to achieve from this? And that's the strategic thinking, the brief taking that we will undergo for all our projects, regardless of scale. And it becomes even more important for master planning, because you're essentially putting place all the different policies and components that will build the wider picture. And essential to this, again, is how we spot check and make sure that the work that we're doing is working with the UN SDGs, which is, as I say, it's a fantastic tool to base your own SDGs on. And I think what's quite useful for us, certainly as a company that have undergone our own process of this, is that it's a global language now that many markets and many companies can all adhere to. And there are so many different standards, so many different literature on these subjects, that actually you need to find something that actually will encompass and bring together many people from around the globe. And that's the only way we're going to target the 1.5 carbon reductions in global temperatures, is by communicating as a global community. So what we always start with is we do need to have strong direction from governments. And certainly when the UK government announced in 2019 that we were going to become a net zero carbon economy by 2050, not everyone knew what was involved to get to that point. But the important thing is it was an important message. And from that, certainly a lot of private sectors was actually quite advanced of the government. So it was almost, forcing the hand through, public pressure to get to that point. But what comes out of that as a subsequent scenario is the various papers that civic, local governments, they will start to generate and realize that actually this is how we get to X, Y, and Z. And certainly that's very, very useful for companies like ourselves, where we're saying, right, in order for us to get, a design, a building, which could be even just, like we're showing over here, a shelter to shield from, rain or sun. But also, the scale of, well, we want to have a community building. So starting from, and then, it gets right down to the point of, are the people happy? How are we monitoring people's well-being? And that's something that, we do a lot of in-house research. And that's certainly an aspect of our work through using technology like virtual realities, is to monitor that important health and well-being aspect throughout the project's life cycle. But you can understand, as an architect, as an engineer, as surveyors, we're working right from the strategic policies right down to, does this product actually work, and how can we improve it? How can we make sure that we're applying flexibility to make sure that we're moving with technology and with people's needs? I think what's very evident is that it's quite overwhelming for not just companies, but also many designers themselves. And certainly at the RIBA, we're working on a series of, how do we help and make sure that the practitioners are literally at the top of their games to answer questions. And when the questions there aren't answers to those questions, that how do we get to that point? And certainly some of the graphics that I'm showing you here are from the UK Green Building Council, which we work very closely with. And all these various understandings of how to reduce your carbon emissions from a whole building perspective, whole life carbon perspective, but also applying that to whether it's a building, to a master plan, to a piece of product design. This is essential, and knowing that steps that you have to make to get to that point. And so what I'm trying to say, though, is that if you don't know the answers, some of the answers are already out there, and it's through collaboration, through dialogue, that we're certainly working with previous clients that we've worked on projects to help them and encourage them to look at various publications and to develop their own strategies. And I think that's probably the first step, where you look at what are you trying to achieve, and knowing that there is quite a lot of resource out there, and there's a technical expertise to help guide you through that. And actually, from a personal level, I found that very rewarding. For since the start of my career, we've been advocating for sustainable architecture, which really is good architecture. Orientate your buildings well. Make sure that the master planning to the point where you're orientating all your buildings, they're functioning and they respond to their climate and the context that they're in. And so certainly now talking to companies where they're saying, right, we want to achieve this, how do we get to that point? It's a fantastic moment to be in, but it's a huge amount of challenges, because we're witnessing climate crisis, unfolding, and with all the various disasters on the news every single day. And certainly when you look at Southeast Asia and the risk of flooding and the impacts of a heavily urbanized city, master planning your cities in a very structured and organized way, which has the ability to adapt and to be flexible. So God forbid if we ever have another global pandemic, how does the city respond to that? These are the key kind of questions that we would pose when we're looking at a project. So it's certainly an exciting time. It's a time where if we plan and work correctly, we will be in a much better position in the future. And it's certainly something that we would advocate for all clients to work with architects and engineers right at the onset, so that you're not just looking at it from a financial perspective, you're applying actual practical solutions to those financial models. And actually that's something that we work, we realize that actually that's quite important. Why don't we work with a group of investors? And that's certainly something that we're doing in Africa at the moment, where we're working with investors to look at funds for governments, and they essentially are, applying a set of rules and principles that will help them guide to, what is essentially green investment. So it brings it back to, what is this all about? It's about giving people the security that they're living in healthy communities. They're living in cities that can respond to, whether it's a global pandemic, to a disaster, and it's making sure that everyone's happy, that they're enjoying life. You live once, let's make it a more enjoyable experience. And these are graphics that have come from UK Green Building Council, and I highly advocate that companies get involved with groups such as Ashwin's group as well, where you come together as a community and you learn. We get together and we talk about, well, actually, how's your net zero journey coming along, and what do you what have you learned through that process? And before there was this culture of oh, we don't want to share too many of our ideas and stuff. Well, actually now this has worked. Let's share the science behind that, so that we can start to determine the science-based targets, which I think is an essential part of when you're designing for smart cities. You have to start recording and distributing data so that we know how to improve as a community. And that's what I'd like to end on, that it's all about community, and it's about providing that security and that climate resilience to those communities. And master planning smart cities is probably the start of it. And we're in that technological era where we can find solutions like Stuart's solutions, where even off grid you can gather power. So I'll end there and look forward to questions and so forth, and pass it back to you, Ashwin.
Thank you, Diba. Yes, master planning smart cities, that is a key area that our government should be focusing on, not just to mitigate climate change, but as you pointed out, also to improve the resilience of a city to the changing climate, and to improve the socio-economic well-being of its occupants. I'm sure there'll be lots of questions by the audience later on. Okay, and last but certainly not least, we have Robert Eason, who will talk about energy efficiency in buildings. Over to you, Robert.
Thank you very much, Ashwin. Okay, so Ashwin, thank you. BMCC, thank you. And Diba and Stuart, thank you as well. Diba, before I actually start, Diba mentioned a couple of things. And one of the things that keeps sticking in my mind, because I'm one of those people that has been banging on this drum for a very, very long time, is data. If you have the data, you can do so much with it. If you know what to do with the data, you can, there's so much you can do with it. And being a business intelligence, having a business intelligence background, data is king for me. And hence the reason why, right in the title of my presentation, we have measure, manage, save, because essentially if you really, if there is no management, sorry, if there's no measurement, there's actually no management. If you don't know what you have to measure, then how do you know how to manage it? But anyway, let's move on. One of the things that we say very, very often here at Eastern Energy is that the greenest energy is energy you don't use. Now, one of the, when we see what's happening in the marketplace, there is very little data available for your energy usage. What do I mean by that? Well, have a look at your energy bill. And it doesn't matter whether you're in the UK or you're in China or you're in any place on this planet. I bet you your energy bill basically tells you how many units you used last month, if you're lucky, and how much you owe, and that's pretty much it. There is nothing about, you know, like if you go to the supermarket, you have an itemized bill. If you go to a hotel, you have an itemized bill. You go to the doctor, you get an itemized bill. But when you're talking about electricity, you have one bill and there is nothing else on that bill. Or perhaps you might have some information about what you spent the month before and the month before. But when you actually try to do the math, it actually, well, here in Thailand, it doesn't work out. I mean, the total is never the same as what's actually stated on the bill in the first place, which makes us scratch our heads as well. So how do you then turn around and say, well, I'm going to save 10% electricity because I'm going to switch off my lights every time I leave the room, or I'm going to switch off the aircon. These are all very, very basic things. You know what? My father, when I was a little boy, was already drumming into my head, turn off the tap when you're brushing your teeth or having a shave later on, not when I was a little boy, or turn off the lights, turn off the aircon. Gee, you know, these were so boring things. You know, Dad, I don't want to turn off my aircon. My room, it's so blooming hot out there. My room's nice and cool. Well, I've been a conservationist through no choice of mine at times, but now it's my choice for a very long time. But the thing that we find is that these are all very basic things. These are behavioral changes which are extremely important in energy efficiency, but these are very basic things that you can do. And most people say we're already doing that. And to that extent, for example, there are some very, very common problems within the energy, within buildings, within factories, within supermarkets. These are all almost identical. First is that they have a lack of resources. There is no energy expertise on site. I mean, can you imagine a 7-Eleven or a KFC that has an energy efficiency manager sitting there going, yeah, this is not efficient. It just doesn't happen. Even in factories who rely on energy efficiency and, you know, a 1% reduction in energy efficiency or energy usage for a factory could be worth thousands of dollars. And even then, they don't have an energy efficiency person, dedicated energy efficiency person. This usually falls on the head engineer or something like that. The next is that energy costs are rising. It doesn't matter where you are. I mean, here in Thailand, we just had a 20%, approximately 20% rise in energy costs. Because obviously the energy company had to recap all the discounts that they gave us, the 2 months of discounts that they gave us during the pandemic. I'm being unkind, I think, not sure. Lack of energy visibility, as I mentioned. You know, when you talk about the electricity bill, you can't say to the energy company, if you can't tell me how much electricity my fridge is using, I'm not going to pay the bill. Energy company usually says, well, don't pay it, we'll cut you off at the end of the next month. And that's really the way the energy companies have us over a barrel. Unconnected equipment. There are many, many different types of equipment, motors, air conditioning systems, fryers, fridges, freezers. And there are many, many things that we call smart devices, or the latest buzzword is IoT devices. These are all things that are not connected to each other. And when you have things that are not connected to each other, how can you have a unified solution? Diba was talking a great deal about, city planning and things. That planning is part of a unified solution. If you plan for everything, then you can produce an outcome that you know the answer to, or you know most of the answer to. And this is, again, when you have the data to do this planning, you have very, very good plans in place to be able to move forward. There used to be a time where you could actually make a statement on your website called the greenwash. We're planting, 1,000 trees this year so that we can offset our carbon. Well, fantastic. I'm glad you're planting 1,000 trees, but can you tell me how much carbon are you actually producing? Can you prove that to me? And of course, most of the time, that doesn't happen. There is no real proof up until around about 3, 4 years, 5 years ago, when business intelligence started coming into that. And there is, of course, the unpredictable equipment failures, again, another very, very common problem. And this is actually a side effect of being able to measure everything, is that you start to get into this realm of predictive maintenance rather than preventative maintenance. With predictive maintenance, if you have a production line with 16 motors, for example, if you're going to do preventative maintenance, you have to actually go through and do maintenance on all of those motors, because you don't know which one is actually going to break or not. Yes, there are sensors that you can put in that have come out relatively recently that you can actually monitor these motors. There are SCADA systems that are supposed to monitor these systems. But here in Asia, the problem is that these SCADA systems are not widely used. And when they are widely used, they are not extensively used. And people sometimes don't even know how to use them because the people that were trained on them have now left. When you're talking about an energy efficiency solution, and in particular the energy solution, efficiency solution that we provide, preventative maintenance is actually part of a side effect of the solution that we provide, because we are monitoring every motor, because we're monitoring it for energy efficiency, but we can also see that, hey, this motor is supposed to be running at, 8,000 RPM. At 85 degrees, it's running at 11,000 RPM, and it's very toasty at 110 degrees. There's going to be a blue flash on this one soon. Alerts start to go out to the engineering team. They can take action on that motor immediately. So that's one of the side effects of the common problems that we have. So what can Eastern Energy do? Eastern Energy are expert energy management. We focus on energy management. We don't do anything else other than energy efficiency management. All of our monitoring is in real-time energy efficiency monitoring. We have proven energy efficiency technology. Our technology has been in the market for over 15 years. And is installed in 42 countries with over 25 billion data points per month. We have remote asset visibility as long as the client gives us that visibility. We don't automatically have that. We can monitor things for the client if they so wish and desire. Really, all of this is driven by the client. Now, previously I mentioned the greenwash as far as a sustainability statement on people's websites, which is a thing of the past. It definitely is, because what we have right now is that because our back end is a business intelligence back end, we can produce extremely accurate sustainability and CSR reporting for our customers. And of course, we can digitalize all their manual processes, or many of their manual processes. Sometimes you don't want to digitalize some manual processes. And as I mentioned earlier, if you can't measure it accurately, you can't measure it effectively. And I would also like at this point to mention one other thing, and that is that energy efficiency is always the bridesmaid, never the bride, because energy efficiency is very hard to see. You go in, if you make your company 40% more energy efficient, it's not something that you can go out and stand next to and say, hey, we're 40% more energy efficient, as opposed to a wonderful new building, green new building designed by Diva with all of the solar panels, with flexible solar panels wrapped around the side of the sunward side, and so on. All of these things you get are really great for politicians and for people to stand next to and say, we've just spent $100 million on this, or $500 million on this. Energy efficiency is not that type of improvement. It is an improvement that you see internally. However, energy efficiency actually, according to the IEA's SDGs, trumps solar or renewables, because renewables at 36% is at 36%. Energy efficiency is at 44%. However, we are complementary technologies. If you add those two together, you get a whopping 80% of the SDGs. So you don't have to do much more to actually get to 100%. So all of these, all our races to net zero and so on, you need both. You need renewables and you need energy efficiency. And finally, I hear quite a lot of people talking about standards. I hear people talking about measurements. I hear people talking about taxonomy, for example. And when it comes to energy efficiency, people just basically say, oh, we don't know how to measure energy efficiency. There's no standard out there. Well, there are standards out there. One is ISO, but ISO is actually more difficult. It's more unwieldy. It's more like a juggernaut. And then there is the IPMVP. IPMVP stands for International Performance Measurement and Verification Protocol. It was a protocol that was developed by the US Department of Energy 25 years ago. About 5 years after that, they spun it off into its own entity, and it's now governed and managed by the Efficiency Evaluation Organization, or EVO. They celebrated their 20th anniversary last year. And IPMVP is the way that you measure and manage energy efficiency. And it is so effective that pretty much all of the EU governments use it. Singapore government uses it, Koreans, the Japanese, the British, obviously, and Australians and Canadians, and many other governments use it. So if you don't already know what IPMVP is, either reach out to me or just Google IPMVP, and you will find a lot of information on it. It is the standard that we need to adopt here in this region, because the Europeans have already adopted it, and it's a global standard. The great thing about the way Eastern Energy operates is that we have both a CapEx model or a shared savings model, which means that there is no, it's purely OpEx, so there's no upfront costs. So if you're looking for an energy efficiency solution, shameless plug here, please do talk to us. Even if we can't help you with a solution, we will actually refer you to somebody who can, if they can. And finally, just to give you a very quick case study, 7-Eleven in Malaysia. I'm not going to go through everything, but I'm just going to cover the main points. 12.4% savings to date, 2.9 million kilowatt hours of energy savings, which would equate to approximately 200 plus cars off the road. And that's 864 tons of CO2 a year that we're not dumping into our atmosphere. And with that, I would like to thank everybody for your attention.
Okay, thank you very much, Robert. A good point there that the behavior of the user is just as important as the right technologies. I think how we use energy is more important perhaps than some of the groundbreaking technologies and more efficient air conditioners, lighting, etc. that we see in the market these days. Okay, so I'll move on now to the Q&A section. At Greenry, we promote sustainability through green building and green township certification. In Malaysia, as it stands as of 2022, less than 1% of the building stock available is green certified. We have more than 1 billion square meters of floor area, excluding industrial buildings. So we're talking about residential, commercial, hospitals, schools, etc. And less than 1% of this is certified. This compares, which is quite far behind our neighbors like Singapore, who are approaching 80% of their building stock being certified by 2030. So to address this, the existing building stock is very, very important. So I'll start off the line of questioning with Robert first. As I pointed out earlier at the start, 2/3 of the building stock that is in place now will be around in 2050. Now, addressing this low-hanging fruit item, getting them up to par, getting them more efficient, because energy efficiency provides that synergy between lowering CO2 emissions and also lowering the cost of operation of a building. So it should be a no-brainer really for buildings to adopt, but unfortunately the take-up rate has not been very high. How long does a typical energy audit take? And what are the average savings possible for buildings that have been around for more than 20 years?
Brilliant question. Thank you very much, Ashwin. Really, depending on who does the audit, it can take anywhere between a month and 6 months, depending also on what you actually want audited. Whether you're doing flow audits, whether you're doing whether if you've got, for example, DIBA at Studio DS involved, then the architects are going to say, we want to know if there are any leakages in the building, all of these things. So all these things can be part of an audit. For Eastern Energy, our audits usually take about a month because we don't do those things. What we are interested really in is electricity and how much electricity a company is using, or a site is using. And if Eastern Energy are doing that audit, it's an electricity usage audit, and that usually takes one billing cycle. And to answer your second, one billing cycle can be a month or 3 months, whatever it may be, right? And to answer the second part of your question, that's really hard to, that's a question that's really hard to answer, because we get asked that question pretty much every time we do a presentation. And, I don't want to give you a how long's a piece of string type of answer, but it really depends, because if you've got a building that was built 20 years ago, but they were using cutting edge technologies, and they've got really, really cutting edge software, building management system, and they're using it properly, then the savings could be anywhere, 1 or 2%, because they are probably already optimized. And if the building is also well designed and well, like for example, a European, gosh, I've just lost my train of thought, but a European standard building that Dibo can probably tell me what the standard is, but it's self-contained. It's actually, the walls are like this thick, and you can't, it's self-insulating, it's built and
Passive house.
set up the right, passive house, thank you very much, passive house. If you've done a passive house, for example, the savings that we can give you are minimal because you've already optimized that. But if like many buildings here in Asia, not all, but many buildings here in Asia are built to, the cheapest possible standard, as long as they pass the building codes and all of that. well, then we'll probably get somewhere up to about 40%, right? So the average, as you saw from my example for 7-Eleven, is between 12 and 15%. Eastern Energy ourselves, we guarantee 10% savings. Otherwise, we won't take the project. Diva.
I might add to that because retrofitting is just hugely important. We've done, we work on audits quite often now, and having worked on retrofits for across my whole career, this is certainly becoming probably the most important part of architecture now, because understanding how buildings are performing. So you can have a passive house, we're becoming passive house certified. And the standards are fantastic, but they don't always quite work for every single environment. They work fantastically well in Germany, and we're certainly working more on passive house projects in the UK. But when you apply that to, say, the Southeast Asia tropical environments, there's a different set of components that need to be looked at. But the environmental audit, where we look at the thermal performance of a building, we look at the technical aspects of, the wall build-ups, but then there's workmanship. And workmanship will always compromise what should be the theoretical energy thermal performance and what is the reality. And working with data that you collect over the years of how the building has performed informs that, but also informs behavioral habits. Certain things that could be changed to bring down those figures. But it's certainly an area that we're doing a lot more work in, and it's certainly some of those principles of passive house, say, for example, we're bringing into our work in Southeast Asia. We're saying, okay, it's a different climate. However, let's work to keeping the heat out as well, and not, over load the mechanical systems, which, take in so much energy. But we just, leaky buildings are inefficient buildings. So yeah, so I thought I'd just add that little bit of information there. But yes, good question there.
Also, I may add one further point, and that is that on the behavioral, see, we can now enhance, these days we can enhance behavior with, I'm going to use this acronym for AI. It's actually not AI. There are very, very few things out there that are real AI. It's actually machine learning. From a tech head to other tech heads, I'm sure you'll understand what I mean. But anyway, because the buzzword is AI, I'll use the buzzword. To actually look at buildings, and for example, take the example of a boardroom. Okay, Monday, Tuesday, Wednesday, maybe a boardroom is used a lot, right? So you may then actually, instead of somebody switching off, switching on, switching off, switching on, which actually possibly could actually create more energy usage rather than less, you may choose to leave that on. But how do you know? Well, that's where machine learning / AI in the background will be actually looking at it and going, yeah, no, you don't need to switch it off. I'm managing it for you, war games, shall we play a game sort of thing. I'm managing it for you, leave me alone. You guys go do what you're doing. But Thursday, Friday, maybe that doesn't work. That room doesn't work. So the AI may, or the machine learning may actually choose to switch off the aircon because the aircon's not going to be used until 3 p.m. On a Friday. So it may actually turn on the aircon at approximately 2:45 to get the room to the right temperature. One of the things that you have a lot here in Bangkok is that you walk into a boardroom and it's roasting. About 10 minutes later, you're glad you have a jacket on. By the time you leave the room after an hour, you may need an ambulance because of hypothermia.
That's not just Bangkok. That's you should try the Middle East.
Yeah. Any hot.
18 degrees, 17 degrees, and it's just it's not necessary.
Exactly.
Right,
but
right.
people can't sit there and turn it down. Okay, back to you, Ashwin. Apologies.
No. Well said. Yeah, I think we should be designing our buildings to be fit for purpose, not overcooling unnecessarily. Adaptive buildings, really. So as you said,
Yes.
we could use technology to adapt and control some of this functionality. And also on the point of good insulation, yes, we do need to seal the building well when we're cooling it, but it should also have the adaptability to be openable if we want to harness natural ventilation, etc., especially in the tropics, where we do have a lot abundance of potential to use natural ventilation with a fairly consistent temperature profile throughout the year. So great. Yes, so energy efficiency, definitely the low-hanging fruit that we should be focusing on. So once we've got the energy efficiency side right, then we need to look at how we can offset the rest with renewable energy as much as possible before we talk about other forms of offsetting and sequestration, etc. Malaysia has huge solar photovoltaic potential. The rooftop potential alone is close to 20 gigawatts, which is about 2/3 of our total installed generation capacity. Unfortunately, in Malaysia, there aren't many incentives. We only have a net metering scheme by the utility provider, TNB, which is available for residential consumers, and there's a limited quota available for non-residential building consumers. I believe the quota that's available at the moment has been fully exhausted. Perhaps, Stuart, you could share with us other forms of incentives that are there in the UK that perhaps we can adopt here to rapidly drive the adoption of renewable energy, particularly solar technologies.
Solar technology really only took off in terms of domestic and commercial installations around about 2009, 2010 in the UK, when the government brought in the feed-in tariff scheme, which incentivized business owners and individuals to have solar installed on their own properties, because there was a guaranteed payback for every kilowatt that was generated. So that created a very big boom, let's say 10 or 12 years ago for PV installations. But it was a sliding scale, and it was always designed to be that way. So after year one, whenever you signed up to the feed-in tariff, that was the level of energy, the price that you got per kilowatt for every kilowatt you generated. But if you signed up and that was for 25 years, if you signed up in year 3, for example, you started on a lower tariff. The reason being is the price of solar, the installation, the number of installation companies out there massively increased. The price of solar panels dropped and associated products. So the payback didn't need to be quite as good. The government cut pretty much to the bone all those feed-in tariffs to new entrants a number of years ago. But right now, for example, so that did hurt the industry. There was a lot of solar farm projects and domestic PV systems that were probably not installed because the incentives weren't so good. But right now in the UK, as Robert alluded to earlier on, with energy prices increasing the way they are, it's an absolutely vibrant industry now, purely based on on self-consumption. If you've got some money in the bank or under the bed or wherever it is, you'll save more money by obviously doing all your energy efficiency drives, which is something which has happened in the UK on the domestic front. So in order to, back in the old days when we had a feed-in tariff, in order to apply for that feed-in tariff, you had to have an energy performance certificate for your property. So they wouldn't basically give an incentive for somebody who had a very leaky house in the first place. You had to do insulation, cavity wall, and some other things before you could get the feed-in tariff. But because energy prices are increasing the way they are, and although energy prices may drop, people, I think this has really scared a lot of homeowners and business owners, especially with the government incentive or the government help on energy prices, which it won't be there indefinitely. So right now, the main driver for PV and any form of in-house or commercial renewable energy schemes is purely the energy price. If you've got the money, you can afford to do it right now, which is obviously not everybody, because there's a cost of living crisis as well. But if you've got the money, then actually by putting it on the roof of your property, in the long run, that system itself is probably going to pay for itself in 5, 6, 7 years, especially with the advent and the rollout of battery storage as well, which has got its issues. But if you can, any excess energy you're not using in the property, you can put into battery storage. The same battery storage system can be used to charge up at off-grid rates as well. So if you get a cheaper rate for certain times of the day, you can program your battery storage to charge at those times, so that you can use that battery storage when you're in a part of the tariff when energy prices are more expensive. So right now it's energy prices which are the main driver in the UK.
Great. Yeah, I guess we're reaching the stage where market forces are dictating the adoption likelihood, right? Energy
Yeah,
prices.
we've got over a million properties, private homes in the UK that have solar on them, and that's in the UK where solar's pretty good in the summer, but you're only going to get 20% of the output in the winter. So it has been a really big adoption, and it's the easiest of all the technologies to install, apart from obviously all the energy efficiency measures which should be done way in advance.
Agreed. Yeah, if there are 1 million homes there should be at least 10 million homes in Malaysia with solar, isn't it? So there you go. We've got lots of room for expansion there. And another thing you touched on was wind turbines, which has been, there's been a very low adoption of that in Malaysia, largely because we have a relatively low average mean wind speed of about 2 meters per second. Is this a hindrance? Is it viable for micro wind turbine installations to work with that sort of wind profile, and what sort of ROI can we expect from an installation?
The micro wind turbines that we manufacture what we see in the market from other people is wind turbines by their very nature don't work particularly well in urban environments, regardless of the wind speed, regardless of the mean average wind speed, because wind turbines, and you can get lots of different designs, but as a rule, they like clear wind. They like a nice open space, and so that's why you see wind farms in the UK, especially, is in open land and offshore. So wind turbines, by their very nature, don't work tremendously well in urban environments. It could be a windy area, but if the wind is coming from from 5 or 10 different directions at once, the wind turbine's just not going to face into the wind. If it's a traditional vertical axis, a horizontal axis wind turbine, it will just spend most of its time just spinning around on its axis, not producing a huge amount of power. Where we see a growth area is with people who have battery storage. So whether it's on a property or whether it's a commercial building, if they want a wind turbine to add a power supply, so an additional power stream into that battery storage, it's not their main, it could be PV that's their main generation source, but actually it just covers, so in a domestic market, it will just cover how much energy you use at night, for example, when everyone's gone to bed. You've got alarms, you've got this, you've got that running in the house, perhaps a dishwasher or something. So a very small wind turbine like that will add into the energy mix into the property. You can obviously get wind turbines, and you see these more in urban environments where they are a vertical axis, so they actually spin around in this sort of direction. So they do work better in urban environments, but again, it's the unpredictability of wind. So, like you say, Malaysia is a fairly low average wind speed environment. Solar is a lot more predictable, and that's why it's always been the technology of preference. As long as you know where it's going and it doesn't have a big shadow across it, you can pretty much predict what it's going to produce over a 12-month period within 5%. Wind, you don't really have that option. So you could be in the windiest place in Malaysia, but if a wind turbine is not sited correctly, it's too close to a tree, it's not high enough off the roof of a building, you can't really calculate the performance of it, especially in a small scale. If it was a wind farm, then obviously you'd put some anemometers and sensors up there for 12 months to monitor it, so you're sure that it's in the right area. But for small wind turbines like we manufacture, they're not ideal for urban environments. That's why you see lots of our systems, those examples I gave, lots of those are on the side of highways, they're on the side of railways, they're in open environments, so we can give quite a conservative estimation of how much power that wind turbine is going to produce each day.
I might add to that, Stuart, because placing of these components are so important. And you're quite right, in the urban environments, it's a challenge to make it all work. And that's why when it comes to the design stages, right from conceptual, solar panels, various other renewables, we will always work to a percentage of how much we want to use as a renewable. We want to put in place in some flexibility that some things might not work, but that needs to be part of the planning process. It needs to be approved. And it should be very much part of the design language as well, so that the overall design looks considered, and not just these bolt-on things where sometimes you see that and you said, okay, yes, it was a building that was designed that didn't accommodate that, but still at least adding some kind of consideration to how that would fit into the existing design. I think it's an important thing, and certainly at planning, it's we have to get approvals for all of these different things.
Yes, thank you. We are approaching close to the end of the session, so I'll have to put one last question through to Diba. I believe you have answered two of the questions that were put up on the Q&A chat.
I was trying to multitask.
Yes, thanks. Can you elaborate on that a little bit more as well? I just thought this one question would probably be a great way to end the Q&A session. In Malaysia, the Ministry of Housing and Local Government has launched a smart city framework. This was done in 2019 to serve as a guide for our local authorities. However, the follow-through has been limited and poorly coordinated, with several authorities just focusing on transport and cashless payments, certain subsets within what we call the smart city. What would you say in a tropical environment, a developing country like ours in Thailand and so forth, are the top three considerations to develop an outcome-driven and sustainable smart city?
It's a big question. It's a very good question as well. And I might just split it into two, where we look at, why hasn't it quite worked? What have been the challenges? And if we look at, say, UK, America, Europe, you generally have, and it's the same with, Asia, Middle East, Africa, you have the national policies. And the national policies and regulations and standards and so forth will set out a parameter. And what you will generally find is the local councils, the local authorities will develop their own plans to support the national policies. And that will be in the form of a framework, which, in order for you to get a project, built in this environment, we need to meet X, Y, and Z of various standards in order for us to make this work. And I think that's very important to remember when we consider, smart cities. It's from a national perspective to a local perspective to a citizen perspective, and there needs to be dialogue between all three institutions, really. And that can be through social media, it can be through a series of key moments in the calendar to see, well, what is working, what isn't working, how do we develop that in the future? So that model should work for any country, anywhere, where civic society and government, national and local, are engaging with one another. And so sometimes when you're at the beginning of that journey, it feels like I haven't got enough information. Certainly in the UK, government would put out a statement, like, say, for example, net zero carbon by 2050. Oh, and by the way, local councils, you need to develop your own plans, but there's no funding for this, or there's very limited funding. And it's working, around those challenging parameters, working with the right partners to develop a framework that works. Now, to simply allow certain councils, because they're saying, well, actually, we don't know how to get to that point for our housing, and that's why we're only going to focus on, painless or, transport and stuff, and, maybe they don't have the infrastructure as well. And I think it's holding those councils to account to say that there's a target that needs to be met, and the best teams are, the best councils are the ones that are made up of the right teams and answer the right questions. And so that's absolutely critical. And I think in recent times, citizens are holding councils to account that, well, actually, we want to have this. So it's your job to help us get to this point, but it's how to get to that point. And there's plenty of examples, as I said, of how to get there. But, you know, when you're looking at the South Asian tropical environments, where you look at the level of heat, the fluctuations in heat, and, you know, it gets dark around about 6:30 predominantly, but also the huge risks of flooding, the monsoon rains, and, you know, climate resilience is so important. And under that banner of climate resilience, you have to say that, well, you know, our houses have to be situated in the right places. Are they going to be situated in a place where it's going to be hugely, you know, flooded? Like, say, for example, in the UK, we have flooding problems as well. And it's impacted the commercial viability of those properties, where some people can't even sell them, and they've lost their assets, they've lost their financial security. And knowing very clearly that you cannot build here, but you can build here. And even with the challenges of certain, you know, you've still got the problems of flooding. How do you design around that? And for there to be a series of guidelines, we start all our master plans, you know, and we have a very, very clear set of guidelines that, okay, well, and actually with all our projects now in Thailand, we're saying we're going to elevate it. You cannot have these structures sitting at ground level. And rather than going into the basement, why don't we just, you know, elevate up? And you certainly, you know, lose the risks of, you know, waterproofing failures when you're looking at that. So when you're looking at those top three agendas, you know, they come under the banner of resilience, and making sure that there is a framework there. Now, sometimes local councils, you know, it's been a struggle in this country as well. But institutions, say, for example, like the Royal Institute of British Architects, like LETI, like Green Building Councils, they've come together to accomplish a certain, you know, criteria. And that's helped practitioners to say, okay, this is what I'm designing to. And certainly, you know, we get involved very heavily in, you know, advocating with our local councils, through our local MPs, and with government, where we send letters to the Prime Minister and say, you know, by the way, this is really important. This is what the built environment is saying. And I think that's critical, that we create, you know, voices, groups that are on the same agenda, the same path. And no one has an infinite amount of resources in terms of finances, and it's making sure that we use those finances in the right place, but keeping people centric, you know, being that being your starting point. Like with all the SGs, we say, right, where are we starting from? Where do we want to go? So I would say the most important thing is resilience. And in an economy or a market where you don't have as much legislation to guide you, I think that's a real opportunity for the private sector to stand up. And that's certainly what the UK private sector has done. They've actually informed government policy. And certainly when it comes to the local councils, then it's that engagement with people, with the local environment, to understand what should be in their framework. But as I say, it's a huge area, and I think probably the biggest thing is mindset change. People have to start changing their mindset of that this is what, you know, buildings should look like, where, you know, you can go, you know, it's not, I'm not going to just pick out, you know, certain countries. This happened all over the place, where they say, you know, a certain image of success and globalization and you know, capitalization is a building with lots of glass. Well, actually it's not. Let's look back and see how communities worked in the past. Look at natural, you know, local vernacular. Let's create an identity for those communities. And in my opinion, they're the most interesting projects, where you use local materials, you use the vernacular of the region, and you know, you're not looking at an image and say, I don't know whether that's in, you know, Texas or you know, UK or, you know, Dubai. I don't know where that is. So there's I would put it in a banner of resilience. So that's the most important. There's no point building all this stuff and it's just going to get washed away. And I think a very big story for all of us to, you know, be really aware of is what's happened in Pakistan, where, you know, so much of the land has just been taken over by, you know, the ocean, the rivers. And, you know, it's a huge wake up call for countries that if you don't do enough, and so many times, you know, you'll see that the countries that are hugely impacted are the ones who have contributed so little to the, you know, to the carbon increases since, you know, industrial times. And that's the heartbreaking part of it. And we know with the international community, you know, they haven't been able to deliver on the pledges for the financial aid to certain countries. So it's playing those financial balancing acts really, really carefully. And you can't do that alone. You have to do that as a community. You know, the ASEAN community is a fantastic vehicle that's actually instigated a lot of change in countries where there were probably a little bit more resistance. So yeah, it's I'm not sure if I've gone for the top three, but certainly climate resilience, I think, is driving smart city designs.
Yeah. Thank you, Diba. Yeah, well said. A two-way communication channel, both push and pull factors are needed. And of course, resilience. No amount of global warming is good. So we are already on a journey towards climate change, adverse climate change, and we need to now adapt and find technologies that can support us on that journey. Okay, we've come right to the end of the session now. I will just pass the floor around very quickly, just a 10-second little final closing remarks. We will start with Stuart, then Diba and Robert, and then we'll hand the floor back to Phoebe. So Stuart, just a quick closing sentence. Thank you.
Yeah, well, just thank you very much for organising today. Thank you, Phoebe, and the rest of the guys there. It's been a really great opportunity to speak to so many of you. And if anyone does have any projects that they're looking at where they're looking for the feasibility of running it off grid using renewables, then please drop me an email, and we'd love to talk to you. So thank you very much.
Thank you. Yeah, Diba.
Yeah, no, thank you. This has been a really great session, and it's been wonderful meeting everyone. So thank you, Phoebe, for organising it, and Ashwin for managing, us three panelists. I think, the key takeaway is that we're all in it together in this very challenging time, and the experience that we've certainly gained from Southeast Asia and how, cultures work as well. We're more than happy to have conversations with any interested party who want to understand a little bit more. It's not about, procuring a project or anything. It's about what have you learned and how can we implement that within our own stuff. And that's why actually we do a lot more work with strategic project discovery to really define the parameters where there may not be that many parameters, but actually how do we guide our design teams, our financiers, our funders to work on a particular project. So ESG definition and strategic thinking, obviously design as well. Happy to have conversations after this.
Great, thank you, Diba. And Robert, your final thoughts?
Firstly, thank you to all the panelists, Ashwin and Phoebe. You guys have worked very hard to organize this. And my final thoughts, this one, okay. The greenest energy is energy we don't use. The faster we get to that point where we are energy efficient, the faster we actually hit our net zero targets. And whether we hit our net zero targets in 2030, 2050, or 2070, all I ask is that for people to not hit their net zero targets when the planet is no longer livable. Other than that, thank you very much, everyone, for your attention today.
Excellent. Thank you, Robert. All right, with that, I'll hand the floor back to Phoebe. Thank you, everyone.
That was excellent. Thank you so much to all our esteemed speakers for your time and for sharing your valuable insights. Thank you to the audience for your attendance and for your questions today. Our appreciation also goes to our partners, Climate Governance Malaysia, for your contribution. Thank you also to the amazing team at BMCC who have worked behind the scenes to make this happen. We also hope you will join us again for our upcoming events. We have the Act Now conference tomorrow afternoon, which brings together renowned sustainability practitioners and stakeholders for the event. This is part of Climate Action Week from today until the 21st of October. And we also have another webinar tomorrow. The topic is Understanding Malaysia's Intellectual Property Landscape. Please visit our website, bmcc.org.my, for more information. And our appreciation also goes to all our partners and speakers. Enjoy the rest of your day and hope to see you again soon. Thank you.
Thank you.
Thank you, everyone. That was actually very, very enlightening. I'm sure the audience really appreciated
Are we?
it. And thank you, Dr. Johan. Yes, that was the end of it.
Okay, I was going to say.
Yeah.
No, well done,
That's-
everyone. That was really
thank-
good.
Yeah, thank you very much for organising as well. Really appreciate it. Thank you.